After a large meal, someone in your family develops severe acid reflux. That heavy, burning sensation is a sign of extreme acidity in the stomach. You look for a remedy among common kitchen items: lemon juice, vinegar, or baking soda. You have to decide which one will help. These liquids fall into two opposing categories. On one side are acids, like lemons and vinegar. On the other are bases, like baking soda and soap. Choosing the wrong substance is dangerous. If you add more acid to an already acidic stomach, you will only increase the level of irritation. Because tasting mystery chemicals is unsafe, we use indicators. These are substances that reveal chemical properties through specific observable reactions. By treating the kitchen as a laboratory, we can identify the chemical makeup of our food and medicine safely. Visual indicators provide the most immediate evidence. You may have seen this when a yellow turmeric stain from a curry gets on a white shirt. Turmeric is a natural indicator. When you scrub basic soap into the yellow stain, the fabric immediately shifts to a deep reddish brown. In a lab, scientists use litmus paper to get the same result. When dipped into an acid, the paper turns red. When dipped into a base, it turns blue. Beyond natural sources, synthetic indicators like phenolphthalein are used to trigger sharp color changes at very specific chemical thresholds. When an indicator meets an acid or a base, its molecular structure changes, altering how it absorbs light. This visual shift confirms the liquid's hidden properties. If color-changing dyes aren't available, we can test chemicals using our sense of smell. These are called olfactory indicators. Finely chopped onions or vanilla extract are common examples. When an acid is mixed with these ingredients, their distinct scents remain completely unchanged. A strong base creates a different result. As seen here, the basic environment dismantles the odor molecules, causing the characteristic scent of the vanilla to vanish. Chemical properties alter the physical structure of odor molecules, proving that acids and bases operate on multiple sensory levels. We can also identify these chemicals by observing how they react with solid objects. When a piece of reactive metal is dropped into a strong acid, it immediately fizzes and produces a steady stream of bubbles. The acid is breaking down the metal. This reaction releases trapped hydrogen gas, which escapes the liquid in the form of those bubbles. This gas is highly flammable. If you bring a small flame near these bubbles, they will ignite with a sharp, audible pop. Acids are reactive agents that break down the molecular bonds of solid materials. Since acids and bases are both reactive, a specific result occurs when they are mixed together in the same space. In this beaker, a pink indicator is used to show a strong base. As acid is added drop by drop, the solution eventually reaches a neutral state, and the pink color vanishes. This diagram shows the process. The positively charged acidic ions and negatively charged basic ions collide and lock together. They mutually neutralize each other, forming harmless salt and water. This is why swallowing basic baking soda helps with indigestion. The base neutralizes the excess acid in your stomach, removing the source of the irritation. You can see this in nature as well. Rubbing a basic dock leaf or baking soda on an ant sting neutralizes the methanoic acid that causes the pain. Understanding these chemical relationships allows for the management of acids and bases using common household items.